Welcome, engineering fam, to our Kaggle competition. 6/30/2022. This is the day that it is due. So we're going to be turning a little bit down to the wire. Continuing on from last week. We are live. Let's go. All right, engineering fam. Welcome to another episode of Get on Code. I'm your host, Steel Engineer. Today, we are continuing on with our Kaggle competition for our June tabular competition. This competition isn't really worth anything. It's just easy practice for people who want to get into data science. You want to have a project to display, etc., etc. Matter of fact, oops, let me get that down. Go ahead and share this in all the social media platforms for me. Let me go ahead and share a couple of these too, because I know for a fact I'm gonna forget later because I've been busy as hell this week. As you can see, we got our notebook open and we're going to be running through a few different imputation methods. I hope it doesn't crash. We'll see. Just give me a second, engineering fam, while I go ahead and share this all the way out. And all right, sorry about that. So go ahead and share it to, well, I'm sharing it to my Twitter really quick. What I'll probably do is I like to put this on my, what the hell is this? I like to put this on my LinkedIn a little later. And bro, what is this? What is this Twitter shit? Like, bro, what are we doing? What are we doing? Okay? What are we doing? Okay? Let's share this to Twitter. Stop playing with me. What the hell? I need to log in to share that tweet. Is Twitter down? I don't think that's not even the right shit, but okay. What's wrong with Twitter, everybody? It was just open a second ago. Hold on. Twitter down? No. What the hell is this? Did I get a message from Twitter? Oh, that is okay. This is my old Twitter. This is weird. Which, of course, is still there. This is the first time this has ever happened. Because then I just had Twitter open a second ago. Something went wrong, but don't fret. It's not your fault. Refresh. So whatever it is, my old Twitter, which is obviously still there, never seen that happen before. What the hell? That's a little weird. Is this happening to anybody else? I've been logged out of my Twitter. Hold on. This is weird, man. I've never, I'm about to just say forget it, but still, like, this is, what the hell is this? This is a Twitter. You know what's crazy? This Twitter right here is supposed to be deleted. Well, I know it's never actually gone, but you know. What the hell? That's a little weird. I'm sorry about this, engineering fan. I didn't anticipate Twitter going crazy like this. For whatever reason, I can't log out to my normal Twitter. I wonder if I could do it from my phone. Twitter down. Oh, love the delays. No, what's up on my phone? 100%. It's up on my phone. Try it one more time. If it don't work, I'm just gonna say forget it. That's weird. Is that it? Oh, there it is. It's back up. Yeah, that's that. My old Twitter did. Who knew that they delete Twitter if you stay logged out of your Twitter page for at least 30 days? I stay logged out to my Twitter, my original Twitter page that you've seen before, even though it's still there. I just can't access it. I don't know, but it's working now. Must have been, I don't know. It's weird though. Whatever. It's working now. It's been down for a few seconds. So yeah, let's go ahead and share this. What is it? Data science. Put a couple of tags in there. Sci-int. I don't want to play super right. Python. Okay. Bev. And yeah, get on CODE. Yep. Okay, so it's, I guess it's back up now. That was weird. But yeah, they basically suspend your Twitter page if you stay logged out for an additional 30 days. And so I had to start a whole new Twitter page. But the one you seen before was my old one. They, you know, and I had logged out a little while ago, and they just was like, yeah, you gotta start a whole new Twitter page. So I started a whole new Twitter page, and yeah, here we are. But anyways, engineering fan, we got it working. All right. Alrighty then. Okay, so let's go ahead and get into it. Okay, so let's go ahead and start it. I'm actually gonna be deleting this because I only got like a couple of hours. Down to the wire. Sorry. Let's upload these because I'm sure I need to. Yeah, I'm not gonna actually mount my drive on this one. I don't think I need this. Right. So we got data CSV. Oh, it's just going really slow. Right. We got our data.csv. We got our submission.csv. All right. Before we're going through the shape. Yeah, like it was before. Okay, whatever. Now we're going. You can actually. I talked about this before. You can actually visualize the missing values. This is why you see that big blank spot right there. And you can plot the correlation matrix. Okay, as I said before, you can see the two blocks are form that diagonal. Let's delete that. Don't really need to use that train df. Let's delete that. Let's delete this EDA. I think it's really pointless, honestly. We may need Seaborn, so let's keep that. We're not gonna need this. We won't need that. We won't need any of these functions for EDA. Variables, okay. This isn't even part of ours. Okay. Get rid of that. I don't think we're gonna, well, I just said we're not gonna be. We are not going to be doing any mounting, so let's go ahead and, well, actually, I might leave this here because I might end up doing some mounting at the end. We don't need this data that, yeah, we already have our data variable. We already had this one. It's probably a duplicate. Okay, so now we try this. We're gonna run into the CCA imputation. Can you all see my comments? I think so. I want to say yes, that you can. Okay, you can see my comments. Just making sure. I'm just kind of doing a pre-chat. All right. Okay. All right. So, actually, last time we left off with iterative imputation. Honestly, we might just get rid of this CCA imputation because it's really kind of useless. This is a complete case analysis. Let me just read this real quick so I can remind myself because I haven't looked at this in like 10 days, so I always forget. All right, so it's quite straightforward method of handling metadata which directly removes. Yeah, this is the one we don't want. We don't want this because remember last time when we just removed all the null values, we lost like, it was something like 60 something % of all the data. So that's not really what we want. So honestly, we can kind of get rid of this because this is going to be a very short program. All right, but let's run through it anyway. Okay, so let's look at the head. 5 rows. You can see all these crazy numbers, but you also see all these non-values. So we haven't actually removed them yet. But we will. So we're gonna now remove the. We're gonna find the columns with no values. We're gonna remove them and put them in this this NA variable. And it's a little for loop, and it just goes through each column and checks to see which one is null. And it finds the mean of that, which is greater than 0, because it can't be 0 and it can't be null. But it can be a negative number. All right. So data NA equals DF with the null variables removed. You can see it shrunk to 8851 to data points at 8,851 and 81 labels. And it drops them all. Data underscore CCA. It's actually going to drop all the NA values based on the rows, which is the 0 access. And it's going to verify a shape. Going to make a copy of that. And Any variables. Okay, so we're gonna have any null variables again. If our data frame variable is null, same thing. If the variable is null, it's gonna find a mean that is greater than 0. No negative numbers. Use a gender column to find the unique values in a column. So right now we have F10, but we can probably do, what are our labels? Like F underscore 10 underscore like 10, 11. If we want, we could really look at each one individually if we wanted to. Something like that. All right, you could just keep going through if you wanted to. Okay. Now, again, this is not the one we want. We're not going to be using this one for a competition because this is just not that great of a method. To just simply remove the methods is like, yeah, you know, screw it, you know. But at the end of the day, the purpose of this assignment is to actually predict which values are null using imputation. Right now, arbitrary imputation is the one we don't want either. Yeah, so they're basically going with this arbitrary imputation. Essentially, we're replacing values with the word missing. Let me start over. I don't want to sound too crazy. We're gonna go through each gender column. This is why it says F, female. And we're going to, when we say impute, we mean replace the missing gender with the word missing. And yep. Again, this is not the one we want either. It's essentially the same thing as the CCA. It's not what we want. Now, frequent category. This one honestly not what we want either. But again, for purposes of demonstration, we're gonna go through it anyway. So same column, the F underscore 1 underscore 0. And then we're gonna group by the training DF. And then of course we're gonna get the count of the total. So it should probably look similar to that. Yep. So you see each unique value is counted once. These are the unique values. So we're finding the unique values for each column, right? And counting them, essentially. So we're getting a sum of each one. And yeah, then we're gonna get the mode, each one. And we're going to use the frequent category imputation. So to be clear, did I use frequent already? It's arbitrary. It's frequent. Okay. Again, this is not one we want to use either, but let's go through it. This technique says to replace the missing value with the variable with the highest frequency, or in simple words, replacing the value with the mode of that column. Basically, the one with the highest frequency is a mode. This technique is also referred to as mode imputation. This is not what we want. All right. And it says missing, when to use it. Data is missing at random, which it is not, and the missing data is not more than 5 to 6% of the data set. Remember, ours is like 65%. So this is, man, we will lose so much data. Our models will be so inaccurate that it's not a good method to use at all. Okay, so moving down. Okay, going back. Now, statistical imputation using the mean. I'm not sure if that was gonna be a great one either. Okay, this is done using statistical values like mean, median. However, none of these guarantees unbiased data, especially if there are many missing values. And of course, we have 65% missing values, so it's not gonna be that great. Mean is most useful when the original data is not skewed, while the median is more robust, not sensitive to outliers, and thus used when data is skewed. It's normally distributed data. One can get all the values that are within 2 standard deviations from the mean. Next, fill in the missing values by generating random numbers between the mean and 2 standard deviations, plus and minus. Right? So let's go ahead and work it out. So before and the after. Okay. So before they had, well, in my case, I had 418 unique values or missing values, and after you have 0. So they replaced it with the within 2 standard deviations, right? A value within 2 standard deviations of the mean and the median, or just the mean. Okay, now we're gonna do a linear regression for best fit. All positive numbers. Yes. Okay. So do correlations, absolute value. Then you're gonna use S. You're gonna unstack it. And then SO is a sort. Is you're gonna sort the values using quick sort. What am I using? It says I'm not. You're connected to GPU runtime, but not utilize GPU to avoid GPU usage limits. Switch to a standard runtime. Okay. Now does that restart everything? Okay, because I wasn't using GPU. Eat up my RAM. Yeah, I gotta start over again. So let's start from here. Arbitrary, statistical. Okay, let's start again from statistical. Shouldn't take too long. Okay, as you work. Oh yeah, I gotta re-upload everything again. Back down. Go back down. Statistical. Let's run it all before. Run before just basically runs everything up until this cell. So I don't have to go through all that again. Alright. Didn't take long, did it? Alright. See, we get random variables too, so it's, random numbers. So it was 418, now it's 456 before and after. Let's do it again. Quick sort, all positive numbers. Yep, for every column of unique values. Gonna do this little. We're gonna plot our little scatter plot. It's probably gonna look crazy. You can see there's a bit of a negative correlation though. Between F411 and F413. Truth be told, I can create a plot with any of the X or Y's columns. Okay, printing F4, blah blah blah, get to sum, 415. 415 missing, and F48, 486 missing. Okay. Alright, as a matter of fact, let me go ahead and hold on, engineering firm. I'm gonna take a brief little break for like a quick second. All right, I'm back, engineering fam. Let's go ahead and get into it. Please don't tell me my thing just crashed. Killing me, man. This is a problem with Colab. This is a problem with Colab, bro. Ugh. Look at this shit. Okay, so let's... Okay, I gotta upload it again. I think that all these imputation methods are just killing the memory. And this is something that you all are gonna have to run into. And you're gonna have to deal with. You're gonna have to deal with hardware limitations, to say the least. Okay, at least my files are still there. Run it again. Run on before. I said run all before. Oh great, because I need to. Now, bet you're all wondering why I just got an error, right? That says error tokenizing data. Expect the 81 fields in line 1886 solid 108. That's because this particular data.csv has been corrupted. How has it been corrupted? It's been corrupted because it was encoded when I went through all this. Like, it still has the settings, right? So I'm gonna have to restart everything, right? Yeah, so it's basically already been manipulated, so much so that it ain't data CSV no more. In fact, there's only 81 fields, right? There's a lot more than that, right? So I'm gonna have to restart the entire thing. So in this case, I would have to disconnect and delete the runtime to get rid of all that stuff that's in the memory, which is why it just crashed. So yeah, we got to do that. Isn't this fun? Yeah. So. Okay. Oh, let's re-upload it again. Yes, I get it. All right. It's almost loading. So you see it down there. It's loading. It's doing its thing. It's just slow. Really slow. Oh God. There it is. And let me get submission as well. Alright, submission. You know what? Let me get everything before CCC imputation. And I'm not going to do any other imputation methods because we're not going to be using them anyway for the competition. Alright. By the way, like, share, subscribe. While this runs, share your social media, baby. Alright, so I'm not going to do CCA. I'm not going to do arbitrary. I'm not going to do frequent category. I'm not going to do statistical. I'm going to start with iterative. Iterative, imputation. Okay. Alright, so what is iterative imputation? That's linear regression. Alright, iterative imputation refers to a process where each feature is modeled as a function of the other features, e.g., a regression problem where missing values are predicted. Each feature is imputed sequentially, one after another, allowing prior imputed values to be used as part of a model and predicting subsequent features. That's actually gradient boosting, right? It is iterative because the process is repeated multiple times, allowing ever improved estimates of missing values to be calculated as missing values across the features are estimated. This approach may be generally referred to as a fully conditional specification, FCS, or multivariate imputation by chained equations. This sounds like gradient boosting to me. Don't let this shit happen to me though. Alright, so yep, gradient boosting. We're gonna be using XG boost. Yep. Alright, so let's go ahead and boost it. This is gradient boosting. Alright. I like to think of gradient boosting as like shadow boosting. This is gonna be sound a little crazy, but it's like gradient boosting is essentially you have a data sample or whatever, and you take the derivative based off of the fact that you already have one sample, and instead of your model needing to estimate everything, each subsequent estimation is based off the previous gradient / derivative of the sample. That means your model does not need to go over that particular sample again, and it saves a lot of time, and it's, you basically are predicting based on the derivative of the original sample. That's why I call it shadow boosting, because you're like using your shadow to figure out the shape of somebody or something like that. But you already have the basic shape of the shadow, so you can you got 80% of it already, so you don't need to do it anymore. That's what gradient boosting is, essentially. Did I run that? Okay, so last time I ran this, it crashed. So we're gonna see, because we're gonna try to fit this imputation method onto the data, so we'll see. See, it keeps crashing. Wait, what happened? What happened? Wait, did I do? Okay. Completing matrix with shape 81858A1. Warning: workspace regressive linear is now deprecated in favor of regred error. Yeah, see, pretty much every time I run this, it pretty much. Maybe I have to do them all at the same time, because maybe that's what's creating the actual error. I mean, within the same cell, I should say. So let's try that. Yeah, it's still crashing. NCCL failure, unhandled CUDA error, workspace, horse tree. Yeah, it definitely didn't work. No, that's not it. That's not it. Okay, that isn't really. I don't think it's gonna work with this data set. Sometimes it just doesn't work with it. I mean, I can tweak it, but I don't really have that much time. We're gonna move ahead with the nearest neighbor. I'm most familiar with KNN imputers. This is kind of entry level modeling, just even understanding the K nearest neighbor. So we're gonna go ahead and try this. And I'll explain it as it's going through the motions. Yeah, I don't think that's gonna participate. Yeah, let's get rid of this. I don't know if I can use that. Alright, so the K&M, and I'm just reading this directly. The K&M imputer class provides imputation for filling in missing values using a KN approach. Okay, by default, Euclidean distance. Euclidean distance is the what is it called? Level L1 distance or L2 distance. Okay. Method that supports missing values. Non-Euclidean distances is used to find the nearest neighbor. Each missing feature is imputed using values from in-neighbors. Nearest neighbors that have a value for the feature. The feature of the neighbors are averaged uniformly or weighted by distance to each neighbor. So basically, your weights are your parameters, and they're judged by distance. To each data point. Okay, so you have one data point, you have two data points that are closest to it, and you can predict the value based on how close it is to the in that cluster. If a sample has more than one feature missing, like come on, then the neighbors for that sample can be different depending on a particular feature being imputed. When the number of available neighbors is less than in neighbors, and there are no defined distances to the training set average for that feature is used during imputation. If there is at least one neighbor with a defined distance, the weighted or unweighted average of the remaining neighbors will be used during imputation. If a feature is always missing in training, it is removed during transform. Okay? Based on the average. Okay. Okay. For whatever reason, this it's weird though that this wouldn't work. I really want to use XGB boost because that's like the most used form of gradient boosting. It's a little weird that it doesn't work though. Maybe it's this GPU history that's kind of throwing it off a little bit. Boost. Based off the GPU history. Reg square. Oh, reg linear. Yeah, that's definitely not going to be it. I mean, I can let it finish, but it's pretty obvious that it's not. Now deprecated in favor of reg squared error, so I don't think that's gonna work. Should I go base off reg squared error? That's definitely not gonna work. Okay, let's think about it like this. Maybe because I'm using a linear regression model, right? It's now deprecated in favor of reg squared error. Maybe it is. Maybe it is use reg squared error. Maybe. It's not gonna work. Invalid input reg square. Valid values are approximation, auto exact, GPU history. Maybe you should, I gotta do a. Let's try prox. Maybe that's a approximation. Basically, you're creating this binary tree method, and it's going. Initially, it was based off the GPU history, but man, that is eating up my RAM. So let's try this approximation. I don't think that's gonna work either. I don't think that's gonna work. Why the GPU history? That's what I should be asking myself. Why the GPU history? Right? So they're predicting it based on the GPU history. Right? But why? Prior to GPU values, part of the model predicted subsequent features. This approach may be generally referred to as a fully conditional specification of multivariate imputation by chained equations. Let's go ahead and stop that. What was the other ones? Let's just try to spell that wrong because it's gonna be giving me a wrong one. Maybe I should get one of these sides. So let's go GPU exact. Work. Kind of just, you're literally just experimenting right now. Just see which kind of works. Try auto. I don't know how accurate that's gonna be though. Accelerations 5. Random state 0. I want to be honestly 0 so it could be reproduced. No, that's not gonna work either. It's saying it's deprecated, so this might not even be getting used anymore. They might have removed it. Let's see for a second. In favor of rec squared error. Really quick, I want to look this up. Of course, you know, I avoid Stack Overflow, but okay, so XG boost reg favor of when you run the package test with current XG boost, it's up to a huge number of deprecation warnings. It looks like reg linear, this is linear regress, is only mentioned by the XGB regressor constructed, but it's part of existing public interface. In fact, the learner objective has to be ranking pairwise or regression linear, and regression linear is required by versions 0.90. I suggest checking the XGB's version and replacing the objective with squared error. If the version is 0.9 or greater, and tweaking the public interface to allow effect underscore learner objective equals rec square error itself, and apply the same logic to pass the appropriate objective needed by the particular XG boost. Or actually, within the XG boost, the current release has some defaults still set to regular despite it being deprecated. Go ahead and open this. This means that even lines like learner equals base S regressor, learner equals XGB regressor that didn't explicitly specify linear are storing warnings. Those look like they can be cleaned up with a helper function that ensures XGB regressor gets a non-deprecated, objective function. If it's deprecated, meaning it was removed, do I have to change the objective maybe? Strategy man. So I put objective and then put reg squared, because I'm thinking you have to change the actual objective from linear regression to, I guess, squared, maybe. And maybe by default, it's linear regression, and it's been changed to squared error regression. And let's change that to maybe I think this linear regression has been deprecated or whatever. Okay. waiting. Let's see what it does, man. I think this iterative imputer is going to be probably our best shot, given that we are using SG boost for gradient boosting. No, it's not doing anything. Alright, you know what? Let's change that back to GPU history. No, man. We'll see. Waiting. Don't forget to smash those likes, fam. Waiting. Waiting, 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 waiting. I think it's actually doing it. I just think it's going slow as God knows what. And I'm starving. Executing. We're at a minute and 30 something seconds now. Not seeing anything. I just don't know if it's actually going through it, but I don't think it's gonna do it. Yeah, it crashed. It crashed. Yeah, it crashed. It crashed, Nick. Yeah, it crashed. I figured it would. Can I run everything before? Hopefully it didn't get corrupted. Oh, hell no. Don't run everything. Ah, crap. It's going to go through everything. Crap. Well, whatever. Nothing takes long. It just takes up a lot of memory. You know damn well ain't nobody paying for Google Colab now. Oh man, let's go. Yeah. I really don't want to do all these imputation methods. They're gonna kill the memory, but correlation matrix here. Yeah. All right, we're back. Okay. At this point, like, at this point, GPU history. Not gonna be participating. Yeah. It's not gonna let me do that again, but. Nope. Nope. Boost. What is it? Exception in GPU history. NCCL failure. Unhandled CUDA error. What does that mean? I'm having issues with CUDA. I have a bug I can't seem to correct. Previously had a bug I can't seem to correct. Please had a GPU. It's functional and working, but I've been able to resolve a new issue today. Example below produces the following error. GPU history, the tree method, max death, ETA 1, sign. I have very similar parameters to me. It's something about this tree method that's giving us this error. Sorry, reading to myself. I kind of hate reading the terminal or the terminal out loud sometimes because it'll sound crazy. GNU.so. See, guys, call. It's more of just trying to figure it out where the error actually is, where the bug is. Title problem, I guess, due to weird runtime. Feel free to reopen if problem says. Nah, man, bro, I've gone through this XGB boost. I'm still getting this NCCL failure. Connection fails sometimes due to wrong network interface. That's not it. I'm using Colab. Maps NCCL shared objects. I resolved it by making sure all workers and clients have exact same file XG boost and NCCL. Second run. This is somewhat tricky for a large data set or a large number in DAS memory. Workers are not immediately cleaned up after a successful run. The second run can compile GPU memory usage and cause NCCL to throw into an error. A workaround to restart all the workers as we parameter are still trying to think about how to release GPU memory after training without deleting the booster, the derivative. First of all, do I know what NCCL is? Because I feel like I don't. Are y'all serious? Okay, this is the Video Collective Communication Library implements multi-GPU and multi-node communication primitives optimized for NVIDIA GPUs and networking. Okay, so why is NCCL throwing me an error? What did I do to you? What did I do to you, NCCL? There's a library providing inter GPU. This is the worker nodes. Communication parameters that are topology aware can easily be integrated into application. NCC implements both collective communication and points-to-point send receive primitives. These are worker nodes. So, cut that out for a second. Yep. Yeah. Me too. Come on. GPU, extraction, GPU, NCCL failure. For whatever reason, the NCCL is throwing me an error. I'm not really sure why. Trying to run Spark SCU sample with Scala. Like done. I get the same error. Space. Yeah. All the settings. Needs to check if the issue was caused by NCCL. Because you run in a single node with a single XGBoost to check if the run. Very good. Let's see. Well, those are iterations. No, we're estimators. I'm just gonna say 1. Did it just crack? Come on, bro. Yeah, this isn't not gonna work. Rerunning it again. I mean, I really want to use XG. Maybe I should. See, this is one of the things that I'm gonna find out in engineering. You're gonna find something, you're just like, damn, I'm gonna need to do more research into this. I'm gonna need to do more research into this. I can still turn it in. I'm not gonna get a very good score on this one, but you know, I just want to turn it in for fun. But it might come to the point where it's like, hey, you know, this model just might not work. This particular data set really should though, but okay. We'll just mark these imputed values at first. Basically switching them between true and false, basically binary-ish. Either it is predicted or it's not. So the missing indicator transformer is useful to transform a data set into corresponding binary matrix indicating the presence of missing value. Either the data is there or it is not. Transformation is used in conjunction with imputation. When using imputation, preserving the information about which values have been missing can be informative. Note that both the simple imputer and the iterative imputer had a Boolean parameter add indicator, false by default. Which when set to true, provides a convenient way of stacking the output. Is basically a lot easier to read. Stacking the output, a missing indicator transformer, with the output of the imputer. Non is used as a placeholder. for missing values. However, it forces the data type to be float. So the data type is going to be float, but it's a none if it's going to be missing. The parameter missing values allows to specify other placeholders such as integer. In the following example, we use a -1 as a missing value. All right. So every time it's missing value, we're going to put a -1. Essentially. At all. For right now, we're going to skip the iterative, and you can see right there, create a little matrix or a little array. 2 by 3 by 1, 2, 3, 4, and for every time, as you can see, every time there's a missing value, we'll put a -1, and that corresponds to true, is that it is missing. Missing value, -1, true, blah 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 blah. Okay, that's okay. All right, so we could not get the iterative imputers to work. A lot of this stuff we can get rid of. We're gonna get rid of all these EDAs and this profile. I don't need this. I don't need this. I don't need this EDA stuff. It's kind of worthless. PCA, worthless. Okay, get rid of all this. I didn't realize I had this many fields. Get rid of all this. I'm gonna get rid of all this, all of it. No, don't need it. 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 I create the heat map. Don't need this. Don't need it. 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 I don't even know why anyone would use TSNE. That stuff is so slow and computationally expensive, right? I don't need this. Don't need it. 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 I don't know why these extra fields are here. Come on. Do I really have this much crap? Now, I was gonna use TensorFlow and you know, all that good stuff for logistic regression, but I'm not gonna need all this either. Yeah. Huh? Let's see. All right. I need a lot of this stuff. I don't really need a lot of this stuff. A lot of it's just extra shit. We got the classifiers. TensorFlow. You can see I was about to go in on a TensorFlow. I definitely will. All right, lessons learned. All right, because even though we replaced our values and we predicted our values, we really could have done better with XG boost for gradient boosting. Actually, a lot of this stuff I'm just gonna be turning in. But a lot of stuff we're not going to be needing. Actually, I got rid of the stuff we pretty much don't need. TSNE, we don't need that crap. PCA, we don't, that stuff is, we don't need that shit. All right. So end of the day, we replaced our, okay, there's iterative, and then, okay, so let's create, one was marking nearest neighbor. Okay, so we created a nearest neighbor imputation. We got to work better on the iterative so we can utilize we utilize XG gradient boosting, XG boosting. For some reason I want to keep saying XGB boosting, but it's XG boosting. Okay. Can we make this a header? Yeah. So nearest neighbors, and then right after that we did marking, I believe. We just marked them. Yeah, and that's where we replaced them with the binary matrix. All right. We predicted the values, you know, just not as good as I wanted to do it, but you know, it's a learning process, man. This is data science, machine learning. This is development. This is coding. You watch this, you're on your way to becoming a data scientist. One thing you'll learn about doing data science is the coding actually is not that difficult, but what is difficult is everything before the coding. Like, do I need machine learning? Is this going to help? Will this solve the problem? Does this particular problem require machine learning for prediction or regression, classification, what have you? Which models am I going to work? Am I going to use KNN? I mean, you can use k-means. You can cluster your data. Okay, and then, unfortunately, we didn't do much data visualization. We had a couple of scatter plots, but with data visualization, it gives you the ability to be able to really be able to explain your data to stakeholders and people who don't know what the hell you're talking about. So that's really what it comes down to. Another thing is domain knowledge. That's going to be very important. Right now, these little Kaggle competitions, I mean, they're just basically give you opportunities to practice this shit. But truth be told, in real life, your data is going to be a hell of a lot more chaotic, and it's you're going to have to normalize it, go in, see, is this feature important? Do I really need this? Etc., etc. Can I apply this classifier or this regression method to better find feature importance? And yeah, man, so it's a lot that goes into it. It's not just the coding, and I want people to, I'm just showing you the coding. I'm just showing you the coding. You need to understand the math. You need to understand, I'll be turning this in about 20 minutes after I'm not gonna do it on camera, obviously, but you gotta understand the math, linear algebra, calc and stats are gonna be your best friends. The Python, the coding, whatever, that's not really the hard part. Also hardware problems. I mean, listen, if I got my little MacBook, but if I really had, like, you know, the computer to run these major, you know, models, it'd be an entirely different story. My computer's not powerful enough for that yet. I'll probably get a new one later, but for right now, it's not. So, yeah, man, this is data science. This is a TPS June 2022. This is feature importance. This is the imputed value practice, essentially. This is just practice, and you should be practicing this stuff as much as possible. Most important thing isn't just to practice the coding, though, it's to understand what the hell is going on. Engineering fam. So, let's go ahead and end it right there. Okay. So we are moving. All right, engineering fam. Don't forget to smash the like, share this away. I really appreciate it. Then we're gonna be doing another one next month. So they're gonna release another one next month, and we're gonna be doing that one. So I appreciate it, engineering fam. Let's move on. Yeah, man. Yeah, man. Yeah, man. All right, engineering fam, man. This has been this Kaggle competition. Get on code, like, share, subscribe. I know I've already said that a few times, but I'm gonna need you to do it again. All right. With that being said, engineering fam, I appreciate it. See y'all next week. More reviews, more coding, more nerd shit. Let's go. Peace.